Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 16th March 2023. The problem statement for today is second smallest number. This problem is based on greedy approach and mathematical operations, and this has been asked in VmWare interview. Let's now open this. Let's go through the given problem statement first. Here it is said the task is to find the second smallest number with a given sum of digits as S and number of digits as D. Okay, so problem statement is quite small. So it is said that we will be given one variable S that represents the sum of the digits, and the number of digits is represented using variable D. So here we have to find the second smallest number using those given sum of digits and the number of digits as D. So here we can see as an input we have got S is equal to 9, D is equal to 2. So the output is 27. That means the second smallest number is 27. So if we can try to find that what is the smallest number. So 18 is the smallest number with the sum 9 and total digits as 2, whereas the second smallest is 27. So here we are given 2 digits. So using those 2 digits, we can form the smallest number with smallest number that is equal to 18, which has the sum is equal to 9. So that is 1 and 8. 1 plus 8 is equal to 9. So how we are so if you try to look at this one, so we have tried using the maximum possible value here on the right side and minimum on the left side, apart from 0 and the 9 itself. Okay, so that's how we got 18 here. And if you look at the second one, then what we have it is done here, incremented the first place value by 1 and decremented the second place value by 1. So 1 became 2 and 8 became 7. So that's how we got 27 as our second smallest number. Let's go through the given example, second one. Here it is said sum is equal to 16, but we have to use three digits. So the second smallest number is 178. First explanation is the 169 is the smallest possible number with the sum is 16 and total digits is equal to 3, whereas the second smallest is 178. So here instead in example 1 we had to use 2 digits. Here we had to use 3 digits. Here the sum was equal to 16. So 169 was the smallest and second smallest is 178. So I hope the both examples are clear that what is expected from this problem statement. So the approach we will use to solve this problem is to start with the smallest possible number that satisfies the constraint, and then we will modify it to obtain the second smallest number. The smallest number with D digits and the sum of digits equal to S has the first digit equal to 1 and all remaining digits equal to 0 except possibly the last one, which is S minus 1. The number can be obtained by setting num of 0 to 1, setting all other digits to 0 and setting num of D minus 1 to S minus 1 if S minus 1 is less than or equal to 9. So this way we will form a number. To obtain the second smallest number, we start with the smallest number and look for the pair of adjacent digits that can be incremented and decremented respectively without violating the constraint that the sum of the digits must be equal to S. We then increment the left digit and decrement the right digit and return the resulting number. Okay, so this is the approach we will be using to solve this problem. So we will be first creating a smallest number, and from that we will modify the smallest number to get the second smallest number, keeping the constraint in mind, and we increment the left digit and decrement the right digit so that we get the second smallest number. I hope this is clear. So using this approach only I'll be solving this problem. So just to save time in typing, I have prepared the solution. I'll explain it line by line. Here also I have given comments against each line so that it becomes easy to understand. Here let me give some breakpoints here so that the complete comment is visible. Here also, yeah, so now all the comments are visible properly. So we will try to see what is being done here. So first what we are doing, we are trying to initialize an array num of size d to store the digits of the number. Then we are starting from the rightmost digit, which is d minus 1 here, and it iterates from d minus 1 to 1. For each digit I, set the value d to the minimum of s minus 1 and 9. Then assign d to num of I and subtract it from s. We are assigning the variable whatever we have got the value which is the minimum between these two, and we are assigning it to num of I. I hope this much is clear. Then after assigning this d to num of I, we subtract it from s. If s is greater than 9, then there is no valid number, so return minus 1. This one. Now what we will do, we will set the first digit of the number num of 0 to s. So this way we will get, at this point we will get the smallest possible number that is stored in this array num. So now what we will do, we will be starting again with the rightmost digit, iterate over the digits from d minus 1 to 1 again. Then for each pair of adjacent digit I and I minus 1, these two I and I minus 1, if num of I is greater than 0 and num of I minus 1 is less than 9, if it is greater than 0 and it is less than 9, then we decrement num of I and increment num of I minus 1. We decrement num of I and we increment num of I minus 1. I hope this is clear. Then what we are doing, then we rebuild the number as a string using a string builder and we simply return it. So after this, so once we have done this operation of incrementing the left one and decrementing the right one, so whatever the number we got stored in this number, we are using string builder to build a string and we simply return that. And if no such pair of digit is found at last, then we simply return minus 1. So this is the given, so this is the algorithm which is used here. So I'll try to explain it with this example of the first one, 9 and 2. So here, if you can see what we are doing here, for this example is 9 and 2. So here what we are doing, we first declare, here we first declare this num array of size d here. So to store the number of digits, here, so here the d is 2. In this case d is 2. So we will create an array with 2 elements. Then what we do, then we loop through the array from the last index position. Here last index position will be 1 because d is 2 and second index will be equal to 0. Then inside this loop we calculate the maximum possible digit we can use for the last index I, which is either s minus 1 or 9. Then we store this value in the ith position to num array and we subtract it from s. We do until we reach the second index. So in this case, here s is equal to 9 and d is equal to 2. So we loop only once. We set I to 1 and calculate the maximum possible digit as mean of s minus 1 and 9. S minus 1, so here s was 9 here, so 9 minus 1 is equal to 8. So here this operation will be minimum of 8 and 9. So we will get 8. So we set num of 1 to 8 and we subtract it from s to get s is equal to 1. So if we subtract this given this value, whatever we have got as 8 from S. So S was initially 9. So 9 minus 1, 9 minus 8 will get 1. I hope this image is clear. Then after this loop, when this loop is ending, so num of I, so num of 1 is 8 and S is 1 at this one. So here then we check S is greater than 9, which means we cannot form a valid number with the given S and D. In this case, S is not greater than 9, so we can continue. So here we can see, we know the first digit of the number is S. So we store the 0th position. So we store whatever the value in S is there in the 0th position of num array. This one. So after this point, after line number 45 here, so here num of 0 is 1 and num of 1 is 8. So that's how we got our smallest number. So total array size is 2. We are getting at index position 0 1, index position 1 as 8. So the total number is, the combined number is, the smallest number is 18. So now what we are doing in the next step, we loop through the num array from the last index 1 to index 0 again. Inside the loop, we check if the current digit is not 0 and the digit to its left, that is num of I minus 1 is not 9. If this condition is satisfied, then we subtract 1 from num I and add 1 to num of I minus 1. Then join the elements of the num array to get a single string using string builder. So here in this case, the example which we are looking at, the condition is satisfied since num of 1 is not 0 and num of 0 is not 9. So we subtract 1 from num of 1 and add it to add 1 to num of 0 to get number as 27. Initially num of 0 had 1, num of 1 had 8, and since this condition is fulfilled, that is not equal to 0 or 9, so this operation is done and we finally get the number as 27, which is the second smallest number that can be formed using the sum of digits 9 and sum of digits as 9 and D as 2. So after converting it to string builder, we simply return it. I hope this much is clear with this given example as well. Let me just cancel it. Okay. So that's all in this coding. So let's try compiling this code. So here we can see we have got the correct output. Let's try submitting the solution. So here we can see it has passed all the test cases and this problem has been solved successfully. So talking about the time complexity of the solution which I have provided, it is big O of D, where D is the number of digits. In the first loop, we iterate over D minus 1 digits here in the reverse order. So the time complexity of this loop will be order of D. In the second loop, we iterate over, we again iterate over D minus 1 digits once in reverse order. In the worst case, we need to iterate over all the digits to find a valid pair. Therefore, the time complexity of this loop is also big O of D. Hence, the overall time complexity of this algorithm is big O of D only. Okay, so I'll be providing the link for this question in the description box. Please do check that. That's all in this video. Please like, comment and share the video and please subscribe to the channel for more upcoming videos. Thank you for watching.